Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is meant for those who have already taken elementary and intermediate algebra. It is for those who are enrolled in a college-level algebra course with embedded trigonometry. If that's you, here we go.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
All right, this is a continuation of section 3.2 in the Algebra and Trig OpenStax textbook for functions, specifically about domain and range of functions. And we've already talked about finding the domain of a function given an equation. So somebody just explicitly hands you the equation of a function. And then we did a couple examples there. Then we talked about how you could find the domain and range if somebody handed you the graph of a function. Notice I didn't say find the range given the equation of a function. It's actually often much more challenging to find the range given the equation of a function. But finding domain is critical. Now, I skipped past that, but now we're going to go into graphing piecewise defined functions because that ends up being kind of a big skill that is important for certain aspects of calculus. So there's that little how-to here because I only write, just to remind everybody, I only write a how-to if you've been pre-exposed to this in the past. So it is assumed that you have graphed piecewise defined functions before, but it's always nice to kind of review them very quickly. So this is the how-to. I'd never teach a how-to if I was actually teaching a topic, but here I'm reviewing a topic. So given a piecewise function and being asked to graph, how do you do that? The idea is really simple. Just graph each piece of the piecewise defined function, preferably using a pencil because you're going to do a lot of erasing. And you want to graph each piece on the same Cartesian coordinate system. After you do that, you'll identify the domain for each piece and then erase the piece. Like if you focus on piece part 1, for example, the first function, you'll erase the part of the function that is not defined on this domain. For example, what we see here, we're going to graph a parabola lifted up 3 units, that's x squared plus 3, and we are going to erase, once we're done graphing that parabola, all of the function for x values greater than or equal to 2, because that parabola should only be drawn for x values less than 2. So that's kind of the idea. And remember, at the end of this, we're going to state the domain and range of this function. Now, as I said, you start with a nice clean graph. So I just put on a Cartesian coordinate system right there. And you'll have to choose a scale. Notice the x values, the important ones are at 2 and 4. Now, if I make my scale somewhat small, it's going to be bad news. So what I'm going to do is go ahead and maybe put this as 1. And I'll go ahead and pause the video while I scale the rest of this. Now, obviously, I've only scaled the x-axis because there's something interesting about the y-axis here. When you're dealing with a parabola, parabolas grow very quickly. They're not exponential in growth, but they grow very quickly. And so if you think about how I've scaled the x-axis, I've allowed for x equals 6 there. But if you try to plug 6 into that parabola, you get 36 plus 3, which is 39, which means that that's going to be pretty far up there. I'm not going to put a 39 on my y-axis, but I'm just saying that it's going to be a little bit of a hard task to find a proper scale for the y-axis. So what I'm going to do is scale the y-axis by 2s. You don't have to do that, but it does actually help out to do that. And you'll see why in a moment. And sorry that those spacings are not exactly perfect. That's okay. All right, so let's go ahead and graph. Again, I'm going to choose normally to use a pencil here, but because I'm using digital ink, that's fine. I'll use red for that function x squared plus 3. So x squared plus 3 is a parabola lifted up 3 units. So its vertex is at 0, 3. And then at 1 and -1, if you plug that in, you'll get 1, 4 and -1, 4. Now, I would not, and see, look at my spacing's already jacked up here. Sorry about that. That's my fault. At least that's slightly better. And I don't need the negative numbers anyway, so it's okay. And at 2 and negative 2, if you were to plug that into x squared plus 3, you would get to 7. So I'll go ahead and do that. These are going to be very rough. Something you should note here is normally you would not point plot to graph a parabola, but when I'm graphing piecewise-defined functions, I find that it often is a little bit better to point plot. Just because it helps out with the graphing process. So here I go. I'll go ahead and connect these up. And that is a semi-accurate graph of y equals x squared plus 3. Now I'm going to go ahead and graph y equals 7. Now y equals 7 is just a horizontal line at 7. I'll use green for that. That's actually not too bad. We could totally graph that out. I can see there might be some issues with my graphing by hand in a moment here, but we'll find out. It's not that big of a deal. We fix things as we go along. That's y equals 7. And then finally, what we're going to do is graph y equals 2x minus 1. And I just need a couple points to graph a line. So 2x minus 1, when x is equal to 0, y is equal to negative 1. I'll use blue. And remembering my scale, right? So if that was 2, here's 1. And so therefore, maybe here's negative 1. And when x equals 1, y will equal 1. Something like that. And I'll go ahead and connect these points with a line. Now that's pretty good. Let me just zoom out a little bit. And that should be the graph of all three functions. Now I'm going to start my erasing project, right? So notice the very first function, the parabola, should only exist from x equals negative infinity up to 2. So on the interval from negative infinity up to positive 2, not including 2. So I'll have an open circle at x equals 2. So I'll go ahead and erase this for any number, the red curve that is, for any number beyond 2. For any x value beyond 2, that is. And again, at 2 itself, the red curve should have an open hole. Now, this is where you have to be somewhat more accurate. If we had continued graphing at 2, and you were to plug 2 into that parabola, it'd be 4 plus 3, or 7. So I'll have an open hole at 2, 7. And that will be fixed in a moment, but we'll go ahead and just pretend as though we have an open hole at 2, 7. All of this, I didn't mean to do that. Okay. All of this otherwise is okay. I just want to erase some of that. It's a little sloppy. All right. And then I go to the next function, which only exists from 2 to 4. Again, I'm going to include 2 here, but not include 4. So the next function is y equals 7. So that horizontal line at a height of 7 will only exist from x equals 2 to x equals 4. So before 2, I'll erase it. Let's see if I can do that here. That's perfect. And then up to 4, I'll keep it, including 4 itself. So let me use my green pen here. Let's see if I can somehow, I'll try to make this a little more solid in here. And I'm not including 4 actually, so let me not include that, right? Because at 4 itself, y equals 7 is not included, right? There we go. But remember, at x equals 2, it is defined to be a height of 7. So it does actually fill in that hole that was originally there. It does fill it in for us. Now here's the thing about graphing by hand. You're about to see. This next one, from 4 until infinity, we get to keep 2x minus 1. Now I graphed this by hand, and so there's going to be some issues here. The main issue is that, well, starting at 4, if you were to plug 4 into that function, you would get 7. So at 4, my line should actually be at a height of 7. And notice, I kind of missed the mark on that. So I'm going to fill that in. At 4, it should be a height of 7. And then it should go up 2 units for every 1 that it rises. So it should actually look like this. Let me connect those 2 points. So I had to erase my terrible graph of that line because it was just off, and I still have pieces of it that are surviving there. But that does happen when you graph by hand, that you might miss the mark a little bit. That's totally fine. Just make sure that in post, as you do things, that you clean things up like I'm doing here. So this is the graph of our piecewise-defined function. Again, I erased the red, green, and blue curves where they were outside the domain. Now, speaking of domain, I should probably write on here that we were going to graph this from, 4, include that 4, to infinity. All right. The last piece here says state the domain and range. Now, if you're watching the videos in order, you already know how to state the domain and range of this graph, so I don't really have to say very much about that. The domain is all real numbers. As you can see, every x value on the x-axis leads to a y value that lands on the curve, the red, the green, or the blue part. And as far as y values for what our curve attains, it goes all the way down to and includes a y value of 3. Otherwise, it climbs forever, right? In both directions, technically, but it only needs to climb forever in at least one direction. So no matter where I'm standing on, or no matter where I am on the y-axis, there is a function either to the left or to the right. There's a function value to the left or to the right. So all that being said, just means that the range of our piecewise-defined function here starts at 3, including 3, and climbs all the way up to infinity. Again, it will never reach infinity. Infinity is a concept, not a number. All right, so that does it for graphing piecewise-defined functions. That's kind of all you really need. One example should get you going for the rest of eternity on graphing piecewise-defined functions.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.